Hello, this is Livy Math, and in this video we're gonna solve this linear second order differential equation. 4x squared times y double prime minus 8x squared times y prime plus 4x squared plus 1 times y is equal to 0. And dividing both sides by 4x squared, we get this equation: y double prime minus 2y prime plus 1 over 4x squared times y is equal to 0. And in general, for a linear second order differential equation of the form y double prime plus px times y prime plus qx times y is equal to 0, where p of x and q of x are functions in terms of x, then we can eliminate the term with first order derivative. We can eliminate the term with first order derivative by substituting y is equal to e to the integral of negative p over 2 dx times v. And so, for this equation that we're solving here, the p is negative 2. So e to the integral of negative p over 2 is e to the integral of, negative 2 over 2, so that's 1. So e to the integral of 1 dx, so that's e to the x. And so, we will substitute y is equal to e to the x times v. And using the product rule for derivatives, we get y prime is equal to e to the x times v prime plus e to the x times v, and y double prime is equal to e to the x times v double prime plus 2 times e to the x v prime plus e to the x times v. And we're substituting this equation and this equation and this equation for y prime and y double prime into this differential equation right here. Then the equation that we will get after the substitution is, after doing the substitution, we get this equation. After we simplify the equation after the substitution, then we will get this equation, which is 4x squared times v double prime plus v is equal to 0. And this is a Cauchy-Euler differential equation. So we will let v is equal to x to the rth power, and so we will get v double prime is equal to r times r minus 1 times x to the r minus 2, and substituting these equations into this differential equation, this Cauchy-Euler differential equation, 4x squared times v double prime plus v is equal to 0, then we get this. So 4r times r minus 1 times x to the rth power plus x to the rth power is equal to 0. And so 4r squared minus 4r plus 1 times x to the rth power is equal to 0. And so, since this is equal to 0, then the auxiliary equation of this Cauchy-Euler differential equation is this thing right here equals 0. So that is 4r squared minus 4r plus 1 is equal to 0. It's the auxiliary equation of the Cauchy-Euler differential equation, 4x squared times v double prime plus v is equal to 0. And the root of this auxiliary equation is r is equal to 1/2 with multiplicity 2. So r is equal to 1/2 with multiplicity 2, so the linearly independent solutions are x to the 1/2, so square root of x, and square root of x times the natural log of x. So square root of x and square root of x times the natural log of x are the two linearly independent solutions of the Cauchy-Euler differential equation, 4x squared times v double prime plus v is equal to 0. And so the general solution for v is equal to c1 times square root of x plus c2 times square root of x times natural log of x, where c1 and c2 are arbitrary constants. And so now we got the general solution for v, and recall that we substituted y is equal to e to the x times v, so just multiply e to the x to v, and then we get the general solution for y is this: y is equal to c1 times e to the x times square root of x plus c2 times e to the x times square root of x times natural log of x, where c1 and c2 are arbitrary constants. So this is the general solution for y for the differential equation which we are solving in this video is 4x squared times y double prime minus 8x squared times y prime plus 4x squared plus 1 times y is equal to 0. Thank you for watching.